Hello student, uh, welcome to the petrochemical lecture number 7. So in the previous lecture we came to know about the properties and specification of petroleum product. Now here we will study about the LPG specification and its properties. So LPG is liquefied petroleum gas. It is a mixture of commercial butane and commercial propane, having both saturated and unsaturated hydrocarbons. So LPG is odorless, but mercaptan is added uh, into it for the smell. So you can see property. The chemical formula for LPG is basically C4H10 and C3H8, and we have the boiling point. It is 20 degree centigrade to minus 27 degree centigrade, and we have explosive limit 1.5 to 9. The vapor density with respect to air, it is 1.8, and specific gravity is 0.53 to 0.54. Appearance is colorless, odor is odorless, and physical state, it is compressed liquid, and vapor pressure at 40 degree centigrade is 1050 kilopascal. That is the vapor pressure. Now you see the LPG specification, the salient features and chemical properties. So you see the the component into LPG, we have C2, C3, C4 and C5. So C2 we have 0.2 to 1, and C3, that is propane, we have 0.2 to 1, and then butane we have volume percent 37 to 47%, and pentane we have 1.5 to 2.5 maximum, and total content olefins, no olefins into the LPG. It is not corrosive. H2S, no H2S, sulfur nil, and calorific value is in kilocalories, it is 12,500 kilocalories per kg into the LPG. No moisture. Now next, the gasoline. Gasoline is refined product of petroleum consisting of mixture of hydrocarbon and additive blending agent. It is called the petrol or motor spirit. The composition of gasoline varies widely depending on the crude oil, that is uh, refinery, that is coming out of the refinery process, and balance of the demand and product specification. The typical composition of gasoline hydrocarbon is 4 to 8% alkenes and 2 to 5% alkenes. Uh, we have 25 to 40% isoalkanes, and 3 to 7% we have cycloalkanes, and iso uh, 4% of cycloalkanes, 20 to 50% of the total aromatic, and we have 0.5 to 2.5% of benzene into the gasoline. So additives and blending agents are added to the hydrocarbon mixture to improve the performance and stability of the gasoline. So these compounds include anti-knocking agent or antioxidant, metal deactivator, or lead scavengers, anti rust agent, that is to remove the corrosion, anti icing agent, upper cylindrical lubricant, detergent and dyes. So these are the compounds that we are including into the gasoline. So at the end of the production process, the finished gasoline typically contains more than 150 separate compounds, although as many as 1000 compounds have been identified in some blends into the gasoline. So you can see this table. We have physical and chemical property of gasoline, properties, in information and references. So molecular weight we have 108, colorless, and pale brown, sometimes it is pink. Physical state of gasoline is liquid. Melting point is it's not melting, so there is no data. Boiling point, initial boiling point is 39 degrees centigrade, and after 10% of distilled it has the boiling point 60 degrees centigrade. After 50% of distillate it has 110 degrees centigrade boiling point, and 90% distillate it has 170 degree centigrade. Final boiling point is 204 degree centigrade. Density is 0.7 to 0.8 gram per centimeter cube. And you have odor, gasoline odor threshold is 0.025 ppm, and other constant factors for partition coefficient we have these log kW value, log kwc value. Then we have vapor pressure at 60 degree centigrade at 465 mm of Hg. So these are the different pressure at different mercury height. At Henry law 20 degree centigrade, the Henry constant value is 4.8 into 10 to the power minus 4 cubic meter per mole. And we have uh, other factors: flash point minus uh, 46 degree centigrade, flammability limit 1.4 to 7.4. So these are the physical and chemical property of the gasoline. Now here you see the major components of the gasoline. You can see the component and their compositions, the percentage of the compositions. So you see the normal alkanes, then we have branch alkanes, then we have total branched, then we have cycloalkanes, then we have olefins, then we have aromatics. So this is into this table, these the composition of alkanes to aromatic is explained, and given that how much C1 is present, how much C7 is present, how much alkane is present, and how much is the aromatic is present into the normal gasoline. Now talking about the naphtha. So naphtha is basically a byproduct that comes from the refinery after the distillation of the crude oil. So naphtha is C5 plus chain of hydrocarbon which is obtained from distillation column of the refinery and known as the straight run naphtha. So naphtha that is obtained from the refinery is called straight run naphtha. So cracked naphtha is also obtained from flue bed catalytic converter unit of the refinery. The same is blended in the refinery along with suitable additive to MS. MS is motor spirit. So straight run naphtha are being marketed for meeting indigenous requirement as well as a mean for export. So naphtha is basically used into fertilizer feedstock to make fertilizers, and it is used in power generation for gas turbine, and it is also a major feedstock for petrochemical plant. So basically we have three types of naphtha. One is LAN, that is low aromatic naphtha, where the aromatic contents are low. High aromatic naphtha, aromatic contents are high, that is called HAN. And then we have special cut naphtha. So we will come to know about the specifications and different properties of the naphtha. So you can see here different the specifications of the naphtha is explained into these tables. See, the specific gravity is at 15 degrees centigrade for low aromatic naphtha, for high aromatic naphtha, and for special cut naphtha. Next is its calorific value. So it will be it is not given here, we will explain you. Then we have rate vapor pressure, that is 0.4 to 0.07. Then we have different distillation in degree centigrade for low aromatic, for high aromatic, and for special cut naphtha. Then uh, the color, say Bolt Max 30 plus, and the total sulfur ppm is 500. The hydrocarbon composition is given over here. Aromatic we have 12, greater than 12 for HAN. Then olefins is percentage volume is around 1 to 1.18.8 to 29.3, and for HAN it is 39 maximum. And you can see the lead content in ppm, ppb. This is for LAN, and this is for HAN, and this is for uh, special cup naphtha. Then you see the chloride content 1.2, bromide numbers that is 0.15 to 0.35. Now next we will talk about the kerosene. Kerosene is basically another product that is coming out of the refinery. So kerosene is generally name applied to the group of refined petroleum fractions, which is considered as a fuel having approximately boiling range 150 to 250 degree centigrade. So these uniform does not this uniform cuts distillate low viscous and good degree of refinement to be fairly stable. So it is used in illuminating oil in domestic needs in the burners such as kerosene were special blends of relatively high boiling fractions with oil or marine animals. So initially the kerosene was used as a oil for illuminating your home lamps. So now we this is further explored in the type of kerosene that is used for different purposes for as a fuel in the aviation sector. So you can see the specifications and properties of the kerosene on left side. The molar mass in gram per mole we have 170 to 34. Then we have boiling point in between this range from 15 to 300 range. Then we have melting point minus 20, density in kg per cubic meter we have 800. Then ignition temperature, flash point, thermal expansion coefficient, viscosity, calorific value, air fuel ratio, vapor pressure, heat vaporization, and octane number. So this is a fuel property of kerosene. Formula mixture of a hydrocarbon, that is from C9 to C16. The carbon number C 9 carbon number to 16 carbon number, that fuel is called the kerosene. Now next, another type of kerosene that is called the aviation turbine kerosene. So this is a special passenger or commercial jet turbines that are often turbo often and are known as jet A or jet A1 or jet B. Special additives avoided moisture, freezing, or ATK, that is aviation turbine kerosene, is that is used as a jet fuel to power the engines of the jet or aircraft or some rockets. So so this type of fuel we are using into the uh, uh, jets or your turbines or your planes. So you can see it is also used in rocket. So this is divided into different types: jet A, jet A1, and jet B. Some special type of moisture and freezing is also uh, is designed this fuel for a special quality. So this product can also be adapted, such as that it can be used for aviation vehicles within the household. So when product is adapted for such a capacity, it is then referred to dual process kerosene. So another it is also called the dual process kerosene. So kerosene is widely used to power jet engines of aircraft as well as some rocket engines. Is highly refined form that is called RP1. So RP1 kerosene is used basically for your jet engine aircraft or somewhere in rocket engines. So it is also used for as a cooking, lighting fuel, and for fire toys such as POI. And in part of Asia, kerosene is sometimes used as a fuel for small outboard motors or even motorcycles. Uh, so, world's total kerosene consumption for all purpose is equivalent to about 190,000 cubic per meter. That is equivalent to 6.7 million cubic feet per day. So this is the total per day demand of the per day demand of, per day consumption of the kerosene in all around the world. So next we have the jet propellant. This is also a type of kerosene that is used in as a jet fuel. So special jet engines or jet turbines are military jet airplanes or helicopters which form at least 75% of fuel and is kept very low or specific additives. So with mixing some special additives, this jet propellant is used into some airplanes, that is military jet airplanes, or in some military helicopters. So this is additives based on the additives. This is JP1, JP2 up to JP8 types. So this is some military jet fuel specification table. You can see the properties of kerosene of JP1, JP4, JP5 and JP7 to JP8, and this is RP1, that is the aviation turbine fuel that is used in mostly in jet planes. You see the property approximately formula is given C 8.5 to H17. This is for JP at JP4, and for JP5 it is C12 to H22, and JP7 it is uh, C12 to H25. So you can see, and so on. For RP1 we have H C12 to H24. This is a H by C is hydrocarbon ratio is 1.99 in JP4, 1.87 in JP5, like this. And boiling range for JP4 it is 140 to 460 and 360 to 495, like this. For RP1 it is 350 to 525, and freezing point is given for JP4, 5, 7 and RP1. Now the average composition aromatic volume percentage is given. Naphthenes, Naphthalenes are given. Paraffins, olefins, sulfur in ppm is given. So now this was all brief information about the technical specification of the kerosene. So for other product we will talk into the next class. Meanwhile, if you have any questions, you can write me in the comment or you can message me. Thank you.